So now we're going to look at buffer preparation. We know the recipe. It has to have a weak acid and its conjugate base salt, or a weak base and its conjugate acid salt. So we need to now learn how to do a calculation of how much of these things you need in order to make these solutions, okay? So to make a buffer with a specific pH, the first thing you have to do is choose the right ingredients, okay? It can't be just any old acid and its conjugate base. It needs to be an acid where the acid form, whether it's the full acid or a conjugate of it, it needs to be one whose pKa value is close to the pH you want. Because remember, in the Henderson-Hasselbalch equation, pH equals pKa. The pH is going to be close to pKa, and this term is to tweak it up and down some, okay? That's its job, to make it higher or lower depending upon this ratio. So you have to choose something that's close to that pKa value, okay? And then once you do that, you'll be able to calculate the ratio that you need of concentrations. It's not the exact concentration, but it's going to be a ratio. So let's say that this turned out to be 1/2. That means you need twice as much A as you have its conjugate base form, and that will give you that. So a 1 to 2 molar ratio, a 2 to 4 molar ratio, either one of those would give you that right ratio, and it just one would be more concentrated than the other. Okay, so that's what I just said. You're going to use this equation to figure out that ratio, and then you can determine how much you need of those things to get you that ratio. So here is a problem. Now I've already told you the buffer we're going to use. We're going to prepare 500 milliliters of a cyanic acid, sodium cyanate, okay, it gives you those ingredients, buffer, tells me that I've got a Ka value for that, and that the pH needs to be 4.80. So I take my equation and I know I need this to be 4.80. And I put in the negative log of the Ka value that's given to me there of 2.0 times 10 to the minus 4. Okay? And this, plus the log of the base, that part we don't know and we're solving for. Okay? That's what we're going to look for. So the negative log here is 3.70, okay? So 4.80 is equal to 3.70 plus the log of the base over the acid, okay? We'll subtract this over to this side, and that's going to give me 1.10 is equal to the log of the base over the acid, okay? My pen writing here. And now how do I get rid of that log? I take 10 to the value on both sides, okay? Because 10 and the log will cancel each other out, and I'll be left with B over A is equal to 10 to the 1.10, which is 12.6. What does that mean? Well, let's bring the A over here. 12.6A is equal to B. Whatever B is, concentration, A needs to be 12.6 times bigger than that. All right? So it asks me how I'm going to prepare this solution. Maybe I first ought to decide what concentrations I want. Let's say I want my B to be, I'll start with my A. I want my A to be 0.1 molar. Okay, so what will my B have to be? It will have to be 12.6 times that number. So it's going to have to be 1.26 molar. Okay, so let's say that that's what, I'll get rid of those, so I don't need those. Boop. All right, that's what we want there. This is what B is going to have to be if A is this value. If I have any ratio of 1 to 12.6, it's going to give me this concentration, and this is a 1 to 12.6 ratio. So now I know what those concentrations I'm shooting for are. I want the A to be 0.10 molar, and I want my B to be 1.26 molar. Well, I need to figure out how many moles I need. I'm making 500 milliliters, so if I multiply by 0.5 liters, I'm going to have 0.05 moles of this, okay? And if I multiply by 0.5 liters, I'm going to have 0.63 moles of this, And this is my A, which was the acid. What's my acid? It's HOCN. HOCN. And this is moles of my base, which was NaOCN. Actually, I wrote it as NCO, but it doesn't really matter. So there we go. We've got how many moles I have of each of these solutions. What do I need to know next? Well, I'd have to figure out how many grams this is. I haven't done that. If I weighed out a certain number of grams of this and a certain number of grams of this and added them to my flask and diluted it to 500 milliliters, I know that I would have a buffer with that pH. Last thing I want to talk to you about with this lesson is buffer capacity. In this problem, I talked about, shooting for these two numbers. I could shoot for all kinds of different numbers as long as it was a 1 to 12.6 ratio. I would have the same pH. It wouldn't matter. But different buffers have different buffering capacities. The amount of acid or base that can be added to a buffer without changing the pH. Okay, so in this situation here, the one on the left is much more concentrated than the beaker on the right. It would take more acid and base to neutralize, to run out of the ability of that buffer to work than the one on the right. So the buffering capacity of the left solution is greater than the buffering capacity of the right solution. But let's look back at this example. Okay. Which one do I have more of? I have more of the base. This thing has the buffering capacity more to neutralize acids than it does have a buffering capacity to neutralize bases, because I have way more of the base in the buffer. So it is going to be a better buffering capacity towards towards acids, because there's a lot of base, than it would towards bases, because there's not as much acid. So with this ratio, we like to keep them a significant amount of both, or one of them would run out of its ability to neutralize pretty rapidly. Okay? So anytime you increase the concentration of an acid and a base in a buffer, by that I mean the buffer acid and the buffer base, then you have increased the buffering capacity of that solution. What else do I need to tell you about that? This is just showing, remember, back to this image, when we had the added acid and added base, we are going to be using up those and adjusting those levels. And you can imagine that at some point you're going to run out of one and peak out on the other, and then it will no longer work for you. All right. We're going to change gears with our next lesson. We're going to start looking at titrations. And you learned about titrations in General Chemistry 1, how to make calculations of how much acid would it take to neutralize a certain amount of base. What we're going to do in these lessons is we're going to be able to monitor how pH changes as you do a titration.